Okay, in the last video we saw a range function. That's a very useful function to just create a testing array and just see output of a particular operation or algorithm just on different kind of arrays. Further, we saw permutation function in np.random package, and we saw that this permutation function actually it shuffles different kind of if array is applied to this permutation function, it actually shuffles all the elements of that array in a random way, in a completely random way. Today we will explore this random package a bit more, and then we will see a reshape function, what that reshape does. Basically this reshape, for example, if you have an array, let's say we have an array with, let's say, 10 elements, and if we call a dot reshape and we give, let's say, 2 by 5, so it will make a two-dimensional array out of A, which is B, and that will be a 2 by 5 matrix, or that will be an array or a matrix with 2 rows and 5 columns. And now we can just work with this B just like it's a two-dimensional array, and we can just treat this B as a two-dimensional array and work with that. It becomes handy sometimes if, for example, we want to test certain operations on matrices. A quick way to make a matrix is just to call a range function, and then whatever the result is, just reshape it into the desired order matrix and test the algorithm. So let's go to the Jupyter Notebook and check this random package a bit more, and then see the reshape function. So let's go to Jupyter Notebook. Yes. So there are a lot of ways to generate these random numbers. One, for example, we already have seen rand int. Another way, for example, array A can be generated like np.random.rand function. So now if we create this, if we pass, let's say, 1,000, a random value array will be generated in A, and each value of A will be a random number between 0 and 1. So all these numbers are just random between 0 and 1. Each number is 0 and 1 random number, and this distribution basically is the distribution of this random number is the distribution is uniform. If, for example, we want to plot the histogram or the distribution of A, it will look like uniform. Let me just give you 1 or 2 plots using matplotlib package, although we will see matplotlib package later on, but let's assume that this is just a plotting package. This is just a package that helps us plotting. Just import that, import matplotlib.pyplot as plt, import that, and after importing that, you just plot a histogram, plt.hist, for example, and pass A, and you can see the histogram is roughly uniform. Everything is equally likely. We can make more bins. For example, we can have bins equals, let's say, 100, and we can see almost all the bins, they are just look like uniform. If we make more and more data set, then they will all look uniform. One more thing we can have, for example, this and let's say B equals np.random.rand n, and that generates normal random numbers or Gaussian random numbers, let's say, which the distribution of the numbers is the bell-shaped curve, for example. So let's just plt.hist B and bins, let's say, equals to 200, and we can see a bell-shaped curve because the distribution of this data is Gaussian distribution. It looks like so. So this random package is this np.random is really important package. It has different, it can create different kind of random numbers from following from different distributions. And doing in machine learning or in statistics, sometimes we need to generate these kind of random numbers for sometimes for testing purposes, sometimes for adding noise of a particular type to test our model and stuff like so. So it's good to have a good grip on np.random package. Okay, next we see reshape function. One more thing, for example, if you want to create, for example, a two-dimensional array of just random numbers, let's say you can call np.random.rand, and you can just pass two arguments, for example 2 by 3, and this C will be a 2 by 3 matrix. If you see the C, it will be a 2 by 3 matrix of all random values. If you see c.ndim, it will be having the dimensions are 2, and it's a two-dimensional array. Further, we can create, for example, a four-dimensional array. C equals np.random.rand, maybe 2 by 3 by 4 by 2, and that's a four-dimensional array with this particular order. So if you see the c.ndim, that will be this. Yeah, so let me just give you an interpretation of what that thing is. There are two arrays that are three-dimensional, and there are two of those. Okay, now each three-dimensional array has three two-dimensional arrays. Wow. So each two-dimensional array has four one-dimensional arrays, and each one-dimensional array has two elements in it. So that's what the structure is. Yeah, get a good look and feel. So let's see the reshape function. For example, let's say we have d equals np.arrange. Let's say we have 100 values, and then we say reshape these 100 values to, let's say 4 by 25. So this D will be a 4 by 25 matrix. So if we just get the shape of D, so that will be a 4 by 25 matrix, or a two-dimensional array with 4 rows and 25 columns. Yeah, so sometimes we want to work on matrices, and we can just plug in these arrange function to generate a bunch of numbers, and then we can reshape those and build a matrix quickly, and then just test the performance of our algorithm or stuff like so. So not only the reshape not only returns the I mean, you can reshape a matrix, and you can reshape an array into more than two-dimensional array if you want to. For example, arrange 100, let's say dot reshape, maybe as 4 by 5 by 5. It's a three-dimensional array. Now this D will be a three-dimensional array containing different values. Yeah, so now you can access it and do whatever you want to do. So not only the reshape, arrange, and permit random, there are other functions as well. np.zeros, for example, if you press Z and you just see the zeros, and then you just press a question mark, you will know what that function is, how can we use it, and so on. Similarly, you can have several other functions. There is an important function ones, for example. You can call that function, and that will generate an array of all ones. You can see how to call that function here. There is np.empty, there is np.empty like. There are so many functions just to create some matrices very quickly, and you want to test your code or algorithms based on those. So yeah, so there are a lot of functions that we want to that we can work on. So next, so there are a lot of functions that can quickly create a NP array and an n-dimensional array. We can quickly create an array, test our algorithm, or use that array wherever we want to wherever we want to use, and we can move on. Just a few functions like arrange, ones, zeros, they are there, or random.rand, random.rand, n, and other functions, they are available. In the next video, we will be seeing the indexing or slicing inside NumPy array, and we will also be seeing the difference of that indexing with or slicing from the ordinary list or the ordinary data structures. What is the difference of slicing in NumPy with the, for example, with the list? We will see that in the next video. Hope to see you in the next video.